Hi everybody. So in this video, we're going to look at adding and subtracting with volumes of revolution. So this diagram shows the region bounded by the curves with equations y equals the square root of x, which is this red one, and y equals 1 over x, which is the blue one, and the line x equals 3, which is here. The region is rotated through 360 degrees about the x-axis, and we can visualize what this would look like. So you can see the area is being rotated around the x-axis by 360 degrees, or 2 pi radians. And you can see as it goes through the other side, we create this composite solid of revolution. And we've been asked to find the exact value of the solid generated. Okay, so because we are revolving around the x-axis, we're going to use the equation where the volume is equal to pi times the integral between the limits a and b of y squared dx. And to work out these limits, we know the upper limit is at positive 3, and the lower limit, a, we can find by setting these two equations equal to each other. So the square root of x must equal 1 over x. We'll take the square of both sides, so x will equal 1 over x squared, and then we'll move this x squared to the left-hand side, so x cubed will equal 1, so the lower limit will be equal to 1. We'll include this in our integral. So now we need to work out y squared, but you can see we have two different equations. So we need to find the y squared for each of these equations. If we look at y equals the square root of x, well, y squared will simply be x. And if you look at y equals 1 over x, well, y squared will be 1 over x squared, or x to the minus 2. So we can find the volume of each of these separate equations. For the red one, we'll have the volume will be equal to pi times the integral between the limits of 1 and 3 of y squared, which is x, integrated with respect to x. For the blue one, we'll have pi times the integral between the same limits of x to the minus 2 dx. To evaluate this integral, we would need to work out the entire region and then take away from that the region under the blue line. So this would be the red integral take away the blue integral. But rather than working these out individually, what we can do is say the volume is equal to pi times the integral between 1 to 3 of the difference of the two functions. So x minus x to the minus 2, all integrated with respect to x. So now we get the volume will be pi. We can integrate this, and we get 1 half x squared minus x to the minus 1 divided by the negative 1. So this negative and this negative will make a positive 1 over x between 1 to 3. And now we can substitute in our limits. So this will be equal to pi. We'll have 1 half of 3 squared, so 9 over 2, plus 1 over 3, minus 1 half of 1, plus 1 over 1. And we can work this out as pi multiplied by 9 over 2 plus 1/3, which is 29 over 6, minus with 3 over 2. So the total volume then is 10 pi over 3 units cubed. Okay,